Hello and welcome to our webinar today about substation virtualization, in which we want to discuss the specifics and concepts of this trend and try to capture the status within the energy industry. My name is Stefan Hufnagel, and today I'm with Anthony Burril, who will share some practical insights in and around substation virtualization in utility projects. At the end of our webinar, we have a short Q&A session, so please feel free to use the Q&A prompt in order to send us your comments or questions. So let's start with a brief discussion about the motivation for substation virtualization. The energy industry is undergoing a fundamental transformation. So first of all, the need for electrical energy rises due to electrification. New forms of energy usage like microgrids or prosumer models and renewable integration poses stress on the grid. This means that utilities need to go into grid modernization and expansion. And this again poses a number of challenges to substation operators. So first of all, bringing legacy assets up to date, simplifying the deployment, the commissioning and the operation of substation assets, enabling the further integration of renewable energy resources into the grid. And as the grid changes, architectures change, the behavior changes, there needs to be innovation in the area of protection functions. Now, substation automation solutions comprise a large variety of hardware and software components from different vendors typically, such as protection, automation and control equipment, HMIs, gateways or security system, for instance. And here, virtualization tries to decouple software and software functions, especially from the underlying hardware, in order to aggregate and centralize functionalities on one single platform. The goal is to gain the required flexibility and scalability of the systems and to use aspects of convergence. So if you think of that software functions do not run any longer on distributed devices, but on a concentrated centralized platform, probably the interaction between the functions could be much simpler. Now, how does this look like in practice? Let's have a look on a simplified but typical architecture of a 61850 digital substation. On the lowest level, on the process level, the primary level, we have our assets and the respective merging units, which deliver the signals, the sampled values in a standardized IC 61850 process bus. Above that, we would have our physical IEDs, the protection devices, bay protection units, bay control units. And again, above that, in the IC 61850 station bus, we would have a couple of higher level applications, such as HMI or an RTU, in order to establish connection to control centers. And here we can see that there is a couple of hardware devices distributed in the entire facility. Now, if we move over to a virtualized and centralized paradigm, first of all, the lower level, the primary level, would be more or less, or would be round about the same. We would still have our merging units, our switch control units, which provide us hopefully with a standardized 61850 process bus. But above that, we would install a central hypervisor. So one platform which is able to run virtual machines on the one hand side or containers on the other hand side, and being able to adopt and host the functions in virtual. So as we had physical IEDs before, now it's virtual IEDs, so a virtual representation of the same functionality. And the higher level functions like the HMI or the RTU could also be hosted on the same platform. That's the principle of centralization and virtualization. And as we see already in this rough picture, in this rough scheme, the number of hardware devices, the number of hardware instances could be drastically reduced. Additionally, other applications, other functionalities like security, firewalls, intrusion detection systems, for example, but also virtualized instances of a phasor measurement unit, for instance, or a virtual merging unit could be deployed and operated on the same platform. If we think about more advanced applications based on machine learning or artificial intelligence, which could help in the sense or in the area of maintenance or operation, also applications like these could be added in the same context on the centralized and virtualized platform. The concept of centralized protection and control is not new. So first pilots of centralized PAC range back almost 50 years. And the first concepts based on the digital substation standard, IEC 61850, have started around 2004, according to literature. And the first virtualized substation pilots have been deployed since 2020. Here I recommend the lecture of a very interesting article in the PAC World magazine, the September 2022 issue, which very nicely explains the history of centralized and virtualized protection, automation, and control, and gives a number of examples of challenges, but also benefits of this concept. Now, let me give a little bit of an intermediate conclusion. So why does the industry go or think at least in the direction of virtualization? It's the scalability and flexibility which is needed from protection, automation, and control systems or functionality, and also higher level applications. If we think about what virtualization can do in like virtual machines, containerized applications, which we already know from the IT environment. So if we think about having the possibility to taking snapshots, backups, or cloning, moving applications across different servers, for instance, or preparing images for testing and so on. So this is quite some interesting use cases which can be generated here or followed up here. On the other hand side, PAC virtualization and substation virtualization is not easy. It's a challenge because, of course, substations and especially protection, automation, and control features are critical. So first of all, you have to find a reliable solution. You probably have to define a migration path also for legacy assets. And the vendor market as well as the technology stack is not yet fully fixed or fully defined. So this is in evolution. Also, standardization needs to follow up, of course, here. And as always, cybersecurity is a very big concern in this environment too. Before now we move on to the practical insights from utility projects, let me explain the role of Xenon and the Xenon software platform in virtualized substations. So the Xenon software platform provides station and control center level solutions like substation HMI, substation SCADA, or substation gateway solutions for utilities. It does that for all types of substations and independent from the specific devices, types of hardware and vendors which are being used in the substation. If we look at the system, at the solution from a technical perspective, first of all, the software has been designed and developed in order to run in different contexts on different operating systems like Windows or Linux, and in on-premise as well as virtualized environments. And the application and the aspects to the application are arranged in a modular way. So around, let's say, the core application of a substation HMI, for example, you can have a substation server eventually in a redundant manner, but also the different protocols to establish connection and control to different devices. Eventually, an IEC 61131-3 soft PLC, which is based on Straton, or virtual RTU application in like a single instance or in redundant in redundant architectures. So all in all, the system provides a very comprehensive solution, and the connection to the process world, to the different devices on the one hand side, but is also capable of nicely tying into modern IT environments and web environments. So now, as promised, we will get some more insights regarding substation virtualization from practical utility projects. For this purpose, let me introduce my colleague Anthony Beuril from Straton Automation. Hello, Anthony.
Hello, Stefan. Thank you.
Hi. Anthony, before I leave the stage to you, let me ask you one question. So from your perception, what is the status of the market? Is substation virtualization and PAC virtualization still something which happens mainly in the labs, or is it something which we can already find out there in the wild, let's say?
Well, it depends on the country, in fact. So there are TSOs and DSOs in certain countries actively thinking about it, developing proof of concept around that. In other countries, it's at a more advanced stage. It's already mainly fine-tuning everything before pushing it on the field, I will say. And in few countries, it's real. So in France, for example, RTE, the biggest TSO in Europe, already deployed 2 digital substations. So today it's not fully virtualized, but I can quickly show you the concept in the next slides I prepared.
Okay, thanks to that. So I guess you will be talking about that specific project. So thanks, Anthony. The stage is yours.
Thank you, Stefan. So we talked about grid modernization, and grid modernization needs, of course, modern structures. So I simply took the pictures you shared, Stefan. So as you said, today we have more and more different power generation sources and different usage. For example, in those pictures, we can see solar and wind generation, and this could fluctuate a lot. For example, if there is a cloudy weather, there is no more solar generation. And the energy consumption also could fluctuate a lot. If you charge 10 electric cars at 200 kilowatts, then you need power generation related to this. So we need a change because this must be managed by substations, of course, and by modern substations. And this change will take a lot of time and a lot of human resources and cost. So of course, as it must last for decades, we must find the best way to do that modernization. So a new kind of substation. We talked about the digital virtualization. So this is the 21st century, you know it. So what could be this new kind of substation? So just quickly about virtualization, you already talked about that, but I took only a few examples that you are or may be aware of. The protection device from ABB, which has been virtualized. From their website, you know, it says one device covers the functionalities of 30 devices. So virtual protection. There are virtual IEDs also. You can find some references on our website. RTUs can be virtualized. Novatec did it, for example. PLCs also. Siemens released their first virtual PLC in 2023. We released our first virtual PLC in 2002, so more than 20 years ago. So this is really our core of market today. And data transfer also is not virtualized, but more digitalized. You know, we went from a lot of wires, of copper wires, to not one wire, of course, but less wires, thanks to IEC 61850. And there are many others, other virtual stuff. We have only half an hour, so we cannot present everything, but of course, the market is really moving on this topic. So roughly, how is designed a digital substation, or at least what is the concept? So we have at first one SCD file, so a system configuration description file, which contains all the services, communication, 850 data, all the functional description of what the substation will do. This SCD file goes into a deployment script. After this deployment script, we can deploy the solution for test and validation. This platform can communicate with virtual devices to simulate and test that everything runs as expected. I mean, all the functional logic, like if this and this condition is reached, is this command sent correctly? And once everything runs well, we can deploy the solution. And this deployed solution will communicate with all the physical devices. Of course, there still is a possibility, as everything is standardized via the IEC 61850. As everything is standard, the deployed solution can communicate with virtual devices, and the test lab can communicate to physical devices, of course. And above that, you have your control center. So basically, this is roughly the overall design of a substation, I would say. So we talk about the future of substations. So the next slide is a question I asked to the audience at SGT 25 in the Netherlands. So this is a fair specialized in energy, in the energy domain. So I asked this question to the audience. So there were TSOs, DSOs, integrators. I said, do you think it's completely out of scope, that we need really a while to go there, or do you think that yeah, it's done already, that we already implemented such a solution? And the answer was really, I think this is an answer that you can find approximately in the poll of this webinar. The answer was really different. People were thinking that that it's magic, and people are already doing this. So we are on the way. It's not ready to use today. I will be honest with you. It's years of development. So it's really we are in today. So before going into the project I talked about earlier, about this digital substation project, just a quick introduction about Straton and what do we do at Straton Automation, because it helps to understand better the topic, of course. So we provide a flexible solution to put automation and communication in any physical or virtual host. So it means that we bring automation in anything. So basically, you have an automation core, you have communication stacks, 850, 101, 104, DNP3, Modbus, OPC UA, anything, all communication stacks. And with this, we create what we call a virtual PLC. And this virtual PLC can run on anything, on any CPU, any operating system, any field bus, any I/O, any physical or virtual device. So it can run on a PLC, it can run on a protection device, on an RTU, on a NIP hypervisor, like the CPAF hypervisor. It can run on a Docker, and it can run on a Windows platform, for example. So in this case, if you already know Xenon, the virtual PLC running on Xenon, it's Xenon Logic in Xenon. So now the project. So when I asked, do you think that the digital substation is real and that it can run? Well, I can tell you now it's real. RT did it, and it's called the Airspace project. So now, if you check for RT airspace on internet, you have a lot of really deep details about this thing, but we don't have time to go deeper. So basically, airspace, it's a substation level automations for substations, and automation algorithms have been developed by RT and implemented in virtual IEDs. So the automation is based on IEC 61131-3 standard, which is the standard for programming PLCs, and executed by the virtual PLC, and the communication is based on IEC 61850. So there are several levels of virtualized functions running in different hypervisors. There are local SCADA automations using Straton, and the gateway towards the global SCADA in 104. So we'll see it on the next slides. So roughly, if we check on those slides, as said, different type of automations have been managed in the Airspace project. Basically, the automation is for alarming automations and for switch breaker failure automations and overload management, very roughly. If we check on this design, we can see that we still have physical devices on the bottom, merging units, transforming the physical signals into sample values or GUs, the process bus, the bay control unit, the protection, and above that, above the station bus, we have all the virtualized function running in hypervisors. So an HMI, an hypervisor based on CPAF, with the virtual HMI running on Windows, the gateway, and the automations. The advantage of using hypervisors is that you can run it in parallel, you can run it in redundant manner. So it's really a well advanced function. And also it allows to have cycle times which can be adapted to the functions. So low cycle times for critical functions and higher cycle time for less critical functions, I will say. So as said, airspace is real. Today, 2 sites are now fully in operations. You can see some pictures here about the substation, which the first one has been released in 2023, and also a bit of view about what is running inside. So airspace in another graphical manner. What is it? So all the configuration has been done by RT on a centralized tool with the specific SCD file. All the algorithms, all the functional definitions of all the logic is inside the SCD file. The tests have been performed earlier on a test platform before being pushed in operation. So if we grow a bit this scheme, we can see that we still have the physical devices, the control units and stuff like that. And above that, we have the hypervisors running the virtual IDs in virtual machines. So several Dockers, several hypervisors, as said earlier. In few numbers, this project manages currently a maximum of 6 different virtual IDs, which are deployed on site. It is expected to have 40 of them in the future. It manages also from 1,400 inputs to almost 40,000 inputs, so it's really a lot. And exchanges are done in MMS and GOOS. The cycle time is from 10 milliseconds to 100 milliseconds, as said, and it can execute a lot of programs in parallel. Really a lot. Just before going after, as I don't know if I said earlier, for the moment, protection IDs are not virtualized yet. So, I mean, we don't want a blockout in France. So, of course, we need to go step by step. So currently, it's not a full digital substation, but it will follow in the next steps. So to conclude this part, it was a bit short, but again, we need to be concise. The airspace project today, it's real. So really a digital substation and with virtual IDs, virtual SCADA, virtual firewall, stuff like that. It's real. It's really running. Straton has been the core of in a way, it's running with a lot of other software, of course. But for this project, it's the core of the ship, I will say. It's supported by the CPAF platform, which is an hypervisor, which is what we saw also at SGT25, a kind of not standard yet, but widely used already by TSOs and DSOs. The first phase has been completed. So today in 2025, 2 sites are already running. The phase 2 will be done in few years with more complex systems, with wider sites, more data, more virtual IDs, more functions. And it's really a good example of IT and OT convergence, because often this term, IT-OT convergence, it's sometimes difficult to understand. When we see this, that everything like virtual IDs in hypervisor running in parallel, communicating with physical devices, it's really, to say, showing that it's real and it can work. So that's all from my part. If you still have questions in the chat or open questions, it's great for you.
Mm-hmm. Thank you very much, Anthony. That was a very, very good description of this project, and I think it shows quite well how new components and independent open virtual components can help to build up new stacks and systematically approaching the concept of centralized virtualized substations. So now I think we have plenty of time for Q&A now, and for this, I would like to introduce another colleague here at COPA-DATA, Jürgen Resch, director of the energy industry team, who has been able, hopefully, to follow up on questions and statements, comments in the Q&A. Hello, Jürgen.
Hello, everybody. Hi, Anthony, and hi, Stefan. Hi, everybody watching us. Greetings from the northern part of Europe here, from Stockholm. Yes, there were many questions, and they are rolling in right now as well. But I could also record some questions during you were talking about this interesting topic, and it seems to be an interesting topic. But let me start with one that is quite simple, I think, which we received. So you talked about centralized and virtualized pack or substations. What is actually the difference between centralized and virtualized?
Mhm.
This is I can answer maybe. So centralized, yes, it's really to localize the all the communication in one point, of course. And virtual substation, in a way, it's really for grouping the data of several power generation plants and consumers. So the virtual substation really helps to create how to say a virtual power plant grouping several functions and automation and communication in one central point, and it helps in the way that it's fully flexible. I mean, if you had another power generation plant there and you want to do some automation on it, the virtual substation is fully flexible. You can update the Docker image with something new. You can update the program. You can update all the logic, all the virtual IDs that are needed. So I think this is the
Okay.
Yeah.
Yeah.
And I think
Anything
also
else, Stefan? Yeah, sorry.
also the virtualization aspect probably contains the separation from hardware to software. So eventually you can take a specific type of hardware or hardware server in this case, and software components can come also from a let's say different or extended ecosystem of providers as like virtual components, something which you can deploy in a virtual machine or on a container, which also means it adds a dimension of flexibility into the whole concept.
Yeah.
Flexibility, but also challenge, of course. It's not something you would just do, but something you would carefully think about how the hypervisor is designed, how the things are set up, how the processes look like.
Yeah. Okay, Stefan, you mentioned in the Packworld magazine an article from Marco Nunes, where if you looked quite close, that his idea or his prognosis for the future was that you could actually move the hardware from the substation into the cloud, right? So what is this about, and why would you do that?
Yeah, I mean, the idea or the vision of having pack components in the cloud, I guess, are very, very long-sighted, let's say, at least. So this is something which you would not do today, but it shows kind of a roadmap where at the beginning, let's say 50, 70 years ago, everything was handled with like electromechanic relays, and then there came the microprocessor-based solution, so the bay protection, bay control units, where suddenly you only had let's say a fourth of the number of devices. Let's say when you start with 500 electromechanical relays, then you would have 100 roundabout microprocessor-based relays. And when you go further in this direction and you do centralization, that's what the article is all about or shows. You could have a centralized solution where you get down from 100 microprocessor-based relays to, let's say, roundabout 5 centralized instances, centralized servers, which would cover the same substation. And then what is proposed is the next step to go virtual, to set up a virtual hypervisor based solution where even these 5 instances before of the centralized one would be further narrowed down to only 1 instance. And then, and we are, let's say, this is already something which is innovation today, something which is still under discussion, something which is not the standard out there. But if you go further, that idea, you would say, okay, why not putting that same stuff? It's software, it's virtualized, we can run it anywhere. Why not pushing it to the cloud? But in fact, of course, we talk about something which is very sensitive, and
Yeah.
hack components, vendors and utilities know that better than us. For a good reason, have been running on dedicated, standardized, tested devices. Yeah? So we are talking about an innovation process here.
Mm-hmm. Understood. But I need to stay on that topic, because we got a question from a well-known person. Greetings to Jürgen Gebert here. He was asking actually the same, but meaning that the virtual protection, automation, control could move kind of towards the control center, or be part of the control center, or very close to the control center room. But then you have connectivity requirements that you need to fulfill. And do we already see kind of standards here, how to make connectivities fail-safe, or to safeguard the connectivity to the substation? No answer? Or was I muted?
No.
All okay. I was just waiting. Anthony, you want to say something, or should I respond?
Maybe, maybe you can, Stefan.
So I would say the question if protection, automation, control would remain in the substation, or if it would be shifted to the control center, is on the one hand side probably something which would have to do with an individual risk assessment of the utility. So would there be additional vulnerabilities or risks if I move it to the control center? Is it like a private network, and how reliable would the network be? On the other hand side, to be honest, I guess it's also something which has to develop probably in the mindset of people, as it's critical stuff. It's critical infrastructure. From the standards point of view, the only thing, there are a lot of securing mechanisms for communication. There are other solutions like HSR, PRP, and so on, which help to fail safe probably communication. But in the end, it could be another type of direction to think about, and an innovation path.
Yeah. Okay. Thank you, Stefan. Let's go to another question which came up several times already. I know you have shown it in one slide, but where do the hardwired signals come from? So where is kind of the change from the hardwired physics into the virtual world?
So indeed, yes, we show it in some slides. So currently there still are, of course, physical devices like the circuit breakers, the stuff like that. And those devices, to be interpreted by the hypervisor, I will say, by the automation, to do the automation, stuff like that, we still need today a merging unit. So all physical signals are coming to a merging unit. This merging unit is transforming the signals in sampled values, MMS, GOOS, and there we can interpret the data. So currently, this is really the gap between the virtual world, I will say, and the physical world. Merging units are things that we still need today, because, of course, if there is, I don't know, a measurement on some power generation plant, we need to transform this.
Yeah. Somewhere you need to digitize the physics, right? Yeah. And this is typically in the merging units. But this guides me to another question. Merging units are something that we know from IEC 61850, right? So you talked about sample values, GOOS and stuff like that. But can I think also of a virtualized environment, a virtualized substation, let's say it in this way, although it's not true. The substation itself is always physical, right? But can I think about a 61850 free version of such a virtual protection, automation, and control?
Yes, of course. Yes, we can. For example, with the Straton software, you can, or Xenon Logic in Xenon, you can simulate an 850 server. So you can do all the logic and program, for example, that if you send, you want to open the circuit breaker, what will be the behavior of the circuit breaker depending on certain conditions. So you can fully simulate a substation today in a virtual environment. I don't know if it answers the question, but
yeah, maybe I can comment here as well. So I have to be careful because maybe literature or somewhere in literature it says otherwise. But I would say that 61850 and the digital substation standard is not a mandatory prerequisite for centralization or pack virtualization, because you can always, let's say, move in and try to centralize thing, try to virtualize thing, run applications and functions in a virtualized manner. I mean, that's what happens with our software, with the Xenon software as an HMI or as a SCADA system already since many years. So virtualization can be done that way too, apart from 61850. But what a standard, or what does 61850 standard achieves, is to standardize among different vendors, different pack components, station level solutions, and so on and so forth. That means we get, with 61850, we get kind of compatibility and interoperability of different components. And in a future where everything runs in a virtualized environment, it would be nice to have this kind of vendor independence in order to eventually profit from a wide ecosystem of providers. So if I can say, I take merging unit from vendor A, I take a protection function from vendor B, and I have an HMI from COPA-DATA, it could all work perfectly together based on the 61850 standard, which means the runtime, the protocols would be there, and also the engineering approach would be streamlined and work nicely along that standard. So then we can profit from it all together.
Mm-hmm. Okay. Let's go into the virtualization part itself. There was this question about the number of IEDs. So today in a physical substation, we have a clear number of IEDs, and we want to virtualize them. And you said something about containers and VMs. So if I have a dedicated number of IED, how would this translate into which number of containers and which number of VMs?
Well, it depends, because what I know from the airspace project is that sometimes when they could, they grouped some functions. So they grouped some virtual IEDs. So I mean, it's not that you have 50 IEDs physically, that you will create 50 Dockers to virtualize these 50 IEDs. So sometimes there are grouped IEDs. So they made some images and some Docker containers with this managing a specific functions, virtualizing few specific IEDs, and when it was needed, there was a specific Docker at a higher or lower cycle time virtualizing this specific function and this specific IED. So there is no real answer. I will say it's really flexible and scalable, and it depends on the project.
Okay. Mm. And Anthony, do you have experience from that project? Because there was this question, who is then actually porting the IED into the VM?
In this case, RT did it. This was really like the kind of requirement from this project. In fact, this is really, from what I know, what initiated this project is that RT, as the French TSO, so there is only one TSO in France, they wish to have, all the knowledge and they wish to have their hands on what they do. So they didn't want to depend on external providers, at least the less as possible. And they wish to have this flexibility about being able to do things themselves. So of course, this is not possible. You cannot internalize it, but
Yeah, you mentioned also the protection functions. They are not virtualized yet, right?
Yeah. Yes, right.
And I guess that, I don't know, some of these big vendors that do protection relays, they do not want to give their intellectual property to RTE so that they can do the porting, right? So typically this would be in their hands. Do you agree?
Yeah, yeah, I agree. Yes, yes. I think it does not. I think it opens markets for them. I don't think that, often when we talk about virtualization and stuff like that, we said, okay, then there will be no more physical protection devices, physical RTU, stuff like that. But what we saw, and as you said, Stefan, or you, Jürgen, at the end, there need to be a hardware to support this thing, virtual. When we say it's in the cloud, it's not really in the cloud. There are virtual devices. So, physical devices, I mean.
Yeah, yeah.
Um,
Okay, this brings me to another question from the Q&A part here. Downtime was one thing, and on the other side, N-1 handling. In the transmission area, you always have an N-1 requirement. That means you have redundant relays. How is this done in the virtualized way? So how do you handle N-1, and how do you reduce downtime when you need to update or change something?
I don't know if Stefan you want to answer or I can maybe. The thing is that from what I know, at least with the hypervisor, you can monitor everything, and it's really easy to monitor if things runs well. So if there is something wrong, we can adapt really, really quickly. Stop this Docker, start another, make an update. So I guess with a digital substation, the downtime is really decreased today. And even from a maintenance point of view, if there is something to be updated, you can do it from the outside, from the control center, deploy the solution from a distant position. So typically, I guess in the future, downtimes, thanks to virtualization, we will be better than with what we have today.
I see. Stefan, how many questions or how many time do we have left for questions?
Time for one more question, if you have one.
Yeah. Because this one I wanted to hand over to you. So there was this question: what does Xenon provide, or COPA-DATA provide with Xenon for making it easy to create a virtual substation?
I would answer to that very general, although there are a lot of details. But in general, I would say that Xenon software platform offers the independence you need to drive that innovation, because Xenon works regardless of which type of substation we are talking about. If we talk about a conventional substation, a digital substation in the different versions like edition 1, edition 2, edition 2.1, or if we talk about a virtual substation. So with Xenon, you always have the freedom to mix things, to typically you have a legacy environment. You not always can start from scratch or in a greenfield manner, and that means you need the tools to connect and to control all the devices which are there. And of course, Xenon gives you all the flexibility which you need in the engineering, and also provides very, very nice 61850 support in terms of the protocols and also in terms of the engineering. But in general, I would say it's a very good partner for utilities to push towards new solutions in a real world wild environment.
Mm-hmm. And it's already now possible to run Xenon on a virtual machine in a virtualized environment. So actually, this job is already done, and you do not need additional tools to make that reality. Okay, yes. That was it from my side. Thank you very much, and I hand back over to you, Stefan.
Thank you. Thank you very much. So that was it for today's webinar about substation virtualization. Thank you for your participation. Thanks for participating in the polls. You will get summary information, a recording, some documentation around our questions or the discussions we had. So thanks again for your participation. Stay tuned and stay tuned to upcoming webinars. That's it from my side. Thank you, Jürgen. Thank you very much, Anthony, and to the team of Straton Automation in France. And have a nice day. Goodbye.
Goodbye.
Thank you. Goodbye.
It used to be fun to create things, right? What about today in the energy industry? What's it like to create today? Complex systems and processes abound, and the flood of data can make life difficult and confusing. Combining these systems and data streams effectively over the long term is often a major challenge. That's where Xenon comes in. The Xenon software platform makes it incredibly easy to run production and infrastructure systems. How exactly does Xenon work? With Xenon, you can capture all of your equipment data in detail and analyze it in real time. Xenon manages and maps systems and processes, helps you to compare data at a glance, and gives you full access to critical information about your equipment. Additionally, Xenon enables you to implement digitalization projects quickly, easily, and accurately. How is the software platform structured? Xenon provides you with a strong foundation of complementary features. The software is fully scalable and provides the optimal combination of security and flexibility. You can build your various applications flexibly on this software platform. Fully automate substations, manage energy distribution, and monitor renewable energy generation. So get started today and achieve your long-term operating goals with ease. Xenon, industrial software that makes your life easier.